Question 11 is saying, the diagram below shows the positions of towns A, B, and C on the Earth's surface. The question is saying the diagram below shows the positions of A, B, and C on the Earth's surface. If it is 0820 at A, what time is it at C? If it is 0820 at A, what time is it at C? So now when you look at A, you find that A is at 20 degrees east, that is our longitude, and then C is at 95 degrees east, that is the longitude. So we have to understand that the Earth rotates at its axis 360 degrees from the west to the east in 24 hours. So if you divide 360 degrees divided by 24, you are going to get 15 degrees. So it means for every 1 hour, 15 degrees is covered. Now, when you are moving from the west to the east, time increases. And then when you are moving from the east to the west, the time reduces. So what we are supposed to do is to find the difference in longitudes between the town A and the town C. Let's do that. So our angular difference between A and C is equals to, since it's 95 degrees east here, that is where town C is, and then town A is at 20 degrees east, we are going to subtract 95 degrees minus 20 degrees. When we subtract, we are getting 75 degrees. So what we are supposed to do is to divide 75 degrees by 15 degrees so that we find how many hours in difference those two towns have. So we have the time difference between A and C is equals to 75 divided by 15 is giving us 5 hours. Now, since C is ahead, it means that we have to add 5 hours to 0820 hours. Let's do that. So time at C is 0820 hours plus 5 hours, which is giving us 1320 hours. We continue. Question B is saying a plane flies from A to B at a speed of 400 knots. How long does the journey take if AB is equals to 4,800 nautical miles? Now, speed is equals to distance over time taken. So we are going to say speed is equals to distance over time. Then what we are supposed to do is to substitute. Where there's speed, we'll put 400. And where there's distance, we'll put our 4,800 nautical miles. Since they want us to find the time, we'll have to solve for t. So we'll do that. Cross multiply. If you multiply 400 times t, you are going to get 400t, which is equals to 4,800. To find the value of t, divide both sides by the coefficient, which is a 400. And then our t will be equals to 12 hours. We continue. Question 12 is saying the length of a piece of wire is measured as 4.5 centimeters. Calculate the tolerance. Calculate the tolerance. Now the tolerance is the difference between the upper limit and the lower limit. So we have to find the upper limit and the lower limit and get the difference. So now, before we do that, we have to know what the least unit of measure is. Our least unit of measure is equals to 0.1. After finding the least unit of measure, find the absolute error. The absolute error is half of the least unit of measure. So if you multiply 0.5 times 0.1, you are going to get 0.05. To find the upper limit, we are going to add 4.5 plus 0.05. That will be our upper limit. To find the lower limit, we are going to subtract 4.5 minus 0.05. Let's do that. So our upper limit will be equals to 4.5 plus 0.05, which is going to give us 4.55 centimeters. Our lower limit will be equals to 4.5 minus 0.05. Our lower limit will be equals to 4.45 centimeters. To find the tolerance, we are going to get the difference. Our tolerance will be upper limit minus lower limit. Where there's upper limit, we'll substitute 4.55. Where there's the lower limit, we are going to replace a 4.45. Therefore, our tolerance is 0.1 centimeters. We continue. The relative error. Calculate the relative error. The relative error is the absolute error divided by the true measure. Now, our absolute error is 0.05 and our true measure is 4.5. So we'll divide that. Now, every time you are given decimals to multiply, if you are multiplying a decimal which has 2 decimal places, multiply by 100 to get rid of the decimal places. So we are going to multiply both the numerator and the denominator by 100 to get rid of those decimal places. So we are saying 0.05 will give us a 5, a whole number, and 4.5 times 100 will give us 450. Take that to its lowest terms. 5 into 5 will give us a 1. 5 into 45 will give us a 9. Therefore, our relative error is 1 over 90. We continue. Question 13 is saying, in the diagram below, A, B, C, and D are points on the circumference of the circle. Center O. DAT is equals to 40 degrees. Angle BDC is equals to 30 degrees. And AT is a tangent to the circle at A. The tangent is the line which touches the circle at one point. So we'll take it step by step. The question is saying, calculate angle CBD. Calculate angle CBD. Now, when you look at this line BOD, this line, you will find that it is the diameter. It is cutting the circle into 2 equal halves. Now, when you have an angle at the circumference, when you have an angle at the circumference in a semicircle, half of a circle, it means that this angle here is a right angle. That one is a right angle. So angles in a triangle add up to 180. So if we add this angle plus this 90 degrees plus that one, angle CBD, we are supposed to get 180. So we are saying angle CBD plus angle CDB plus angle BCD is equals to 180 degrees. We are going to substitute. So we are saying this angle 30 plus this 90, since it's at the circumference in a semicircle, plus angle CBD should give us 180 degrees. So when we add 30 plus 90, we'll get 120. Angle CBD plus 120 degrees is equals to 180. We'll transpose the positive 120. It will become a negative. Therefore, our angle CBD will be equals to 60 degrees. We continue. Calculate angle BAC. Calculate angle BAC. Angle BAC is that one. So what we are going to do is to find the same segment. This angle should be equals to that one. So we are saying angle BAC, in fact, angle BAC is equals to 30 degrees because they are in the same segment. This is the segment. So we are saying angles in the same segment of a circle are equal. So angle CBD should be equals to angle BAC. So our angle BAC is equals to 30 degrees because it is in the same segment. We continue. Calculate angle AOB. Calculate angle AOB. Now, angle AOB, it is the angle at the center of the circle. So, the angle at the center is twice the angle at the circumference. So, what we are supposed to do is to find angle BCA. This angle here is half of angle AOB, or angle AOB is twice angle BCA. So let's find this angle. We can find this angle by starting with the tangent and the chord. AD is a chord, AC is a tangent. So the angle between the chord and the tangent is equals to the opposite angle of the segment. So if this is 40 degrees, it means angle ACD, this one, is 40 degrees. Now we know that this one is a right angle because of the semicircle. It is in a semicircle. The angle in a semicircle is 90 degrees. So to find angle BCA, we are supposed to subtract 90 minus 40, which is going to give us a 50 degrees. So if this is 50 degrees, it means angle AOB is twice 50. So we are supposed to multiply by 100. So we are saying angle AOB is equals to 2 angle ADO. Since we know that angle ADO is 50, multiply that by 2. Our angle AOB will be equals to 100 degrees. We continue. Question 14 is saying in the diagram below, BCD is a straight line, AB is equals to 12 centimeters, AC is equals to 20 centimeters, and angle ABC is equals to 90 degrees. Find the value of cos ACD. Find the value of cos ACD. So we are looking for that one. Now, we don't know what BC is. But since we have been given this triangle and it is a right angled triangle, it means that we can use Pythagoras theorem to calculate BC. Pythagoras theorem states that in any given right angled triangle, the square on the hypotenuse, which is the longest side is always opposite the 90 degrees, is equals to the sum of the squares of the adjacent sides. The adjacent sides are those sides which are next to the 90 degrees. So our adjacent sides are BC and 12. So let's do that. So use Pythagoras theorem. Our AC squared will be equals to BC squared plus AB squared. When we substitute, we'll find that our BC squared, the missing side, will be equals to 20 squared minus 12 squared. If you multiply 20 by itself twice, you get a 400. Multiply 12 by itself twice, you get a 144. 400 minus 144 will give us 256. To find the value of BC, we'll introduce the square root on both sides. Our BC will be equals to 16 centimeters. So we are going to replace the 16 centimeters here. Then now we can find the cos. Cos is adjacent divided by or over the hypotenuse. So we are going to substitute. Our cos ACB is equals to BC divided by AC. So where there's BC, we'll put our 16, and where there's AC, we'll put our 20. So we can always take this to its lowest terms, which is going to give us 4/5. Now, since this is a straight angle, which is 180 degrees, angle ACD is in the second quadrant, and cos is negative in the second quadrant. So our cos ACD will be equals to negative 4/5. We continue. A and B are points with coordinates negative 3, 3, or A and B are points with coordinates, open your brackets, negative 3, 3, and 5, open your brackets, 5, 9, close your brackets, respectively. Find the length AB. Find the length AB. So to find the length, we are looking for the distance. It is still Pythagoras' theorem. So we'll find the difference in the x coordinates, square it, plus find the difference in the y and square them. So we'll call this one x1. negative 3 will be our x1, positive 3 will be our y1, 5 will be our x2, and 9 will be our y2. Then we'll substitute. So we are saying 5 minus, we have a negative 3 there, plus 9 minus 3. Every time you have a minus and the negative, this is the same as plus. So we have 5 plus 3 giving us 8 squared plus 6 squared. If you multiply 8 by itself twice, you get 64. Multiply 6 by itself twice, you get 36. So if you add 64 plus 36, you get 100. So we are finding the square root of 100. Which number are we supposed to multiply by itself twice to get 100? 10. Therefore, the distance or the length AB is 10 units. We continue. Question 15 is saying A varies directly as B and as the square of C, and A is equals to 30 when B is equals to 2.5 and C is equals to 2. Find the value of K, the constant of variation. So we are going to say A varies as B, we'll put our B, and the square of C. So we have A varies directly as B and the square of C. Now, since we are looking for a constant, we'll replace with variation with equals and then include a constant. So our A will be equals to KBC squared. To find the value of K, we are going to substitute. Where there's A here, we'll replace a 30. Where there's B, we'll replace a 2.5. Where there's C, we'll replace a 2. And then we are going to solve for K. Let's do that. So if you multiply 2 by itself twice, you are going to get a 4. Multiply 4 times 2.5, you are going to get a 10. To find the value of K, we'll divide both sides by 10. Our K will be equals to 3. That is our constant of variation. We continue. Value of A when B is equals to 2. Value of A when B is equals to 2 and C is equals to 3. So we are going to substitute. First, we know that A is equals to, where there was K, the constant of variation, we'll replace a 3. Then we have BC squared. Where there's B, we'll put a 2, and where there's C, we'll put a 3. Let's do that. So if we multiply 3 times 2, we are going to get a 6. Multiply 3 by itself twice, that is 9. So our 6 times 9 will give us 54. We continue. Values of C when A is equals to 300 and B is equals to 4. So we are going to replace. Where there's A, we'll put a 300. Where there's B, we'll replace a 4, and then we'll solve for C. Let's do that. So we have 300 is equals to 3 times 4, which is 12 times C squared. So what we are going to do, to find the value of C, we are going to divide both sides by 12 first. Our C squared will be equals to 25. To find the value of C, we'll introduce the square root on both sides. Which number are you supposed to multiply by itself twice to get 25? It is a 5. So our C will be equals to plus or minus 5. So if you multiply negative 5 by itself twice, you get a 25. Multiply positive 5 by itself twice, you get a 25. So our C is equals to plus or minus 5.